is we've done examples where you go in and somebody has, let's just say, so random person, Bob. Bob has $10,000, which he deposits. And then he does not touch it. So no deposits, no withdrawals for 15 years. And we can find his balance or his interest. But is that very realistic? No, it's not, because that's not how we function in like banking, right? And who has a giant chunk of money that they go down and they stick it in the bank and then they never add any more money to it. They never take any money out of it. And then they go, well, in 10 years at this interest, I'll have so much money. Cool. We don't really do that. That's not really how we function as a society. We're kind of relatively fluid. I mean, CDs do function that way. We talked about CDs. But typically speaking, if you're saving money,
Like a savings bond.
well, like a savings account, you're putting money away, like you want to buy a house in 10 years, and so you start saving money up for a house. You don't say, well, I want a deposit of $20,000, so in 10 years, so I'm going to put away this much money now, and then the interest earned, and then I'll have $20,000 in 10 years. You put away so much money a month. I mean, that's how people tend to save. I'm going to put away $100 a month or $50 a month, or I'll put away, $500 a year, or, it's in increments. Because unless you win the lottery, the reality is you don't have usually a giant chunk of money, unless you did put some away every month, right? I mean, that's usually how you get the giant chunk of money. So what we want to do is we want to look at realistic. So what we've been doing is called the future value of a single deposit investment. That's what we've been calculating, and that's when your balance grows to some point in the future. And that some point in the future is your T in years, okay? And then we calculate that and we use the compound interest formula. Okay, we'll take our example of Bob, $10,000. So we have $10,000 that we're putting away, and I said 15 years, but I didn't give it a rate, so we'll just say that the rate was 3.5%. Okay, so we're going to put away, how often do you want it to compound? Monthly. Okay, cool, monthly. That was the other me talking. Okay, so we're going to say that he's got his 3.5% and it's compounding monthly for 15 years. This is what we've been doing. So 12 times 15 is 180. So I'm going to do 0.035, divide that by 12, add 1 to it, raise it to 180, and then multiply it by Bob's 10,000. And at the end of 15 years, he'll have $16,891.68. Okay. That's single deposit investment. You put one chunk of money away and you just let it sit there. But again, this is not very realistic. What's more realistic is a periodic investment. And periodic investments is when you put the same deposit away on a regular basis. So let's say you get paid every 2 weeks. And let's say you have direct deposit and you have $20 of your paycheck stuck in your savings account and the rest of it goes into your checking account to get spent. You'd be depositing $20 every 2 weeks into your savings. So that would be a periodic deposit, $20 every 2 weeks. So we could do 20 every 2 weeks. You could do $50 a month. You could do weekly, you could do daily, you could do every 6 months, every year, but it's going to be the same amount over the same period of time. That's a periodic deposit. So when we have that, this is that formula. Okay. B is still our balance. All the letters all mean the same thing. It's just set up differently. Okay. P is the principal. But in this case, the principal is not a set amount that you, like one big chunk that you stick in at the beginning. This is the periodic deposit. It's still a principal because it's still money we're putting into the account. We're just doing it on a regular basis instead of one giant chunk all at once. You okay? R, there's 2 of them. R is still our rate as a decimal. N, there's 3 of those. So number of compounds per year, that didn't change. And then T, right there. Don't want to circle it because I'll run out at the end, but T is the time in years. Okay, so what this formula will tell us is if we have a bank account and we know it gets 2% interest and we put $20 a month away every month for 10 years, how much money we'll have at the end of that time. This is more realistic to what people actually do. This is a more useful formula. The other ones are good for, doing quick calculations, but this one's a more useful, everyday, real world kind of thing. Use that formula. Rich and Laura are 45, and they open an account at Rhinebeck Savings Bank. They want to gain enough interest by their retirement at age 65. They're going to deposit $5,000 a year into an account that pays 4.5% interest compounded annually. Now, I forgot to mention, your deposit period and your number of compounds per year, they have to be the same. So if your account compounds daily and you're putting away, say, $30 a month, you need to divide that by the number of days in the month to know how much is going in per day. That has to match. I forgot to mention that. This is good because they're doing an annual deposit with an annual compounding, so it already matches. So our formula, we've got principal times 1 plus the rate divided by the compounds, raised to the power of the compounds times the number of years minus 1, and all of that is getting divided by the rate divided by compounds. So here's their deposit, $5,000, that's P. There's their rate, that's their annually, and their T. They're 45 now. They want to do this when they're 65, so T is going to be 20 years. So I'm going to do 5,000. My rate is 0.045 divided by 1. Oh, darn it. I wrote that too close. Move that over. Hold on. There, do that. Okay, times 20 years minus 1, and all of that will be divided by 0.045 divided by 1. Okay, 0.045 divided by 1 is just 0.045. So I can simplify this into 5,000. And 1 times 20 is 20. Okay, so I'm going to write out all the steps, but you wouldn't have to write all this. But it's going to be 5,000 times 1.045 to the 20th minus 1. Okay, 1.045 to the 20th. And I'm just going to 4.11 dot 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 minus 1 all over 0.045. So then I'm going to subtract 1. Multiply it by 5,000. And then divide it by 0.45, or 0.045, sorry. Okay, so if they start putting $5,000 a year away, in 20 years, they will have $156,000. Now, if you take 5,000 and you multiply it by 20, you get $100,000. That's what we got to figure out now, is how much interest did they earn. So if we take 5,000 that they're putting away every year, we multiply it by 20, they're depositing $100,000. They'll actually have $156,857.11. So they're actually going to earn $56,000 in interest. Well, $56,857.11 in interest. Now we have Linda and Rob, and they're going to do an online savings that's 3.6% annual interest compounded monthly, and they're going to deposit $1,200 a month. So we want to know how much is going to be in the account in 10 years. Okay, so again, formula. Okay, principal, rate, time, compounding. So 1,200. My rate is 0.036 divided by 12. I'm going to have 12 and 10 years. So the first thing I do is I divide 0.036 divided by 12. Oops, that's not what I meant to do. and that goes in two places. And then the next thing I do is 12 times 10, which is 120. That goes up there. Add 1, so you get 1.003. Raise that to the power of 120, and you get 1.4325 stuff. Subtract 1 from that, and then multiply it by 1200. And then you divide that 0.003. Okay, so $1,200 a month at 3.6% interest will get you $173,000 in 10 years. You want to figure out how much of that is interest, you would just take, okay, so 10 years times 12 months is 120 deposits times the 1,200 that you deposited. So you'd actually be depositing 144,000. So you'd have 33,000 in interest. Yeah, that wasn't right. Oops. Okay, that's too big. Let's try that again. $29,022.87. Done simple interest, which is the principal times the rate times the time, and then we've done your basic compound interest, which is P times 1 plus R over N to the NT. We've done continuous compounding, where E is a constant, 2.718. And now we've done future value of periodic investments. Okay, now this is when you know how much you want to deposit and how often, and you want to find the total money later. Okay, so we're going from now into the future. So I know I can put away $20 a week now. How much will I have in 10 years? Okay. The next thing we're going to do is backwards from that. So I want to make sure everybody understands. This formula is I know how much I'm going to put away now every month or week or whatever, and I'm going to figure out how much money later. Like I don't have a set amount of money in mind. I just know I can put away $20 a week. That's what I can afford. That's what I'm going to do. And in 10 years, I'll have blah. This one works backwards. Okay. Present value is like now, current value of a deposit made in present time. Oops, present. Okay. present value of a single deposit investment is how much money do you deposit today to meet a set goal in the future. So you know in 5 years I need $10,000. Like I know what my goal is. How much money would I have to deposit today to have $10,000 in 5 years? So it's going backwards. What we were just doing is I know I can put away $20. How much will I have in 10 years? Now I'm saying I need $10,000 or whatever in 10 years. How much money do I have to put away today to get there? Does that make sense? So present value of a single deposit investment is solving for how much a one-time deposit So this is how much is this one-time deposit that you need to make today to meet this future goal that you have. Okay, so and then you have the present value of a periodic deposit investment, which is how much should my deposits be? Okay, so let's say my goal is in 5 years to have $10,000. I need $10,000 in 5 years because I'm going to buy a house or whatever. The present value of a single deposit tells me how much money I need to deposit today to never ever touch for the next 5 years and have $10,000. And then the present value of a periodic investment tells me how much money I need to put away like every month, starting now, to have $10,000 in 5 years. Okay, so this is, the first one is the kind of the unrealistic. You put away one giant chunk and then in 10 years you have so much money. And then the second one is you put away money every month. And it's to meet a set goal. This is very useful because maybe you want to go on a trip through Europe and you know it's going to cost you $10,000 because you're going to go for a whole summer and you're going to tour Europe and it's going to be $10,000. You figured it all out. And you want to do it in 5 years. You can figure out how much money you need to put away every month to be able to afford to go to Europe for 3 months in 5 years. Does that make sense? So this one's these are very useful. This equation is for the single deposit formula. So this one tells you deposit some amount of money now and you'll meet your goal in the future. This is your goal amount. So if you want $10,000, your $10,000 would go here. This is your deposit. And that's a one-time deposit. Okay. Mr. and Mrs. Johnson know that in 6 years their daughter Ann will attend state college and she needs $20,000 for her first year of tuition, and they want to put into account today some amount of money to have $20,000 in 6 years. So this is the goal. So this is the capital B. There's our time. Here's our rate. And compounded annually is our N. So the formula is B divided by 1 plus R over N to the NT. We want $20,000. Is 5% interest, so that's 0.05. It's going to compound once a year for 6 years. So $20,000 divided by 1.05 to the sixth. So I'm going to raise 1.05 to the sixth and then divide $20,000 by that. Okay, so in order to have $20,000 in 6 years, they have to have $14,924.31 today. We want $100,000 in 10 years for college. So our goal is 100. Oops, I put a B there. That's not a B, that's a P. If I wrote the formula, I wouldn't do that. I want $100,000, and I want it in 10 years, and I've got an interest rate of 3.8%, and I'm going to compound daily. Okay, so 0.038 divided by 365 is going to give me 0.000104111, and 365 times 10 is 3,650. Okay, so I'm going to add 1 to that decimal, and then I raise it to 3,650. And so I get $100,000 divided by 1.462255666. Let's take off that last 6. Don't like that number. Okay, so if I want $100,000 in 10 years, I have to deposit $68,387.49 today. This is a very realistic kind of scenario, all right? When you buy an air conditioning unit, let's say, or an air conditioning system, you know how long they're going to last, about. They'll tell you, like the one you buy, it'll say has a life of 10 years, 15 years, 20 years. Now, it might last a little longer than that, but you know if you buy a 10-year air conditioner that in about 10 years you're going to need to replace it. So a few years before you know you're going to need to probably replace it, you go ahead and start saving up the money for it so that when it does go, you've got the money to replace it. And that's what Nick here is doing. He wants to install central air conditioning in his home in 3 years. And he knows that it's going to be $15,000. Now, he's installing brand new central air. If you just buy a new unit, it's not that much. It's like $4,000. This is like if you're running all the duct work and everything else. Okay, so he wants to deposit money every month into a savings account to save up this $15,000. We don't have the formula for this yet. So first I have to give you the formula, and the formula for present value of periodic deposits. Okay. Okay, we do the balance that we want times our rate divided by our compounds, and that's over 1 plus the rate divided by n raised to the nt minus 1. So what this tells us is how much money you put away every month. Okay, so Nick needs to save $15,000. That's our balance. So here's B. There's T. There's R. Monthly, that's N. So our rate is 0.04. We're compounding monthly. And we've got 3 years to go. Okay, so 0.04 divided by 12 is 0.03 repeating. Oh, sorry, 2 zeros. Now what I usually do on these is I kind of try to run out the top, because a lot of times I get one of these kind of decimals that's not a nice ending decimal. So I go ahead and multiply that times the 15,000 and I get the number. So that 0.003 repeating times 15,000 just gave me 50. Then I come back. Now I know that this is that 0.003 repeating again, but I go ahead and do that division again. Add 1 to it. And then I raise it to the power of 36, because this is going to be 36 right here. And I get 1.127271874 minus 1. So I just go ahead and subtract 1 from that. And then, since I have this kind of calculator, I haven't rounded anything in the actual calculator. I did the top, and that came out an even number. And then I did the bottom. I did 0.04 divided by 12 plus 1 to the power of 36 minus 1. I never retyped the numbers or anything. I just did it all together. And if I do 50 divided by, and then on this one I push second function answer, it'll work. On other calculators can't necessarily do that. Oops. Oh, darn it. I pushed the wrong button and turned the thing off. Hold on. I get $392.86. So this is his monthly deposit. So if he puts away this much money every month, it says round up to the nearest $100. Sorry, I didn't read all that. Let me round up to the nearest 100. So we're going to round up to $400. If he puts away $400 a month, in 3 years, he's going to have enough money to do that whole air conditioning. Just as a comparison, I'm going to calculate the other thing where we do single deposit really quickly. His single deposit, if he had done a single deposit, would be $13,306.46. It is much easier to put away $400 a month than it is to have suddenly out of nowhere $13,000 to stick in a bank account. Just, again, unless you win the lottery, in which case, cool, more power to you.